and the slope for this one is negative 1 over LVO. Okay, and this is our current ripple. Let me actually do it this way. This is our current ripple, delta IL, which is the slope times dt. So it's 1 over L VI minus VO times dt. Or I can write 1 over L VO times 1 minus d times t. Okay. The other thing that we saw is that the average of IL is the same as average of IR, because the average of IC is equal to 0 based on amp second rule. So this is also equal to VO average over R. Okay, and just like to put more information here, this distance and this distance are going to be exactly equal. This is delta IL divided by 2. This is delta IL divided by 2. If you don't know why this is the case, this is like, if you remember, like we did the average of this shape and then we did the average of this shape before the midterm. If you find the average of this shape is always going to be in the middle of this height. So this is like why the average is going to be exactly in the half point between the delta IL, the current ripple. Now, what I want to ask you, I can't wait for you to answer, but I'm just going to ask you, maybe you can pause and think about it. What's going to happen if our load has a higher resistance? If we increase the resistance, what's going to happen here, right? If you increase the resistance, what's going to happen to the current? It's going to get smaller, right? So as you increase the resistance, you're basically reducing the current that goes through your output, and it basically means that the average of your inductor current is also decreasing, right? So it means that you're basically like shifting this shape towards the horizontal axis. So let's say like we increase this, like this shape might look like this, then look like this. Then we get to a point that we are, and it's going to continue, so it's going to increase again and decrease again, so it's going to continue. We get to a point that our inductor current in the beginning of the period is 0 and at the end of it is 0. Here it wasn't 0, like it was a positive value, right? Here it just gets 0 like momentarily, like for like a very small amount of time, and then it would just increase again, right? But at this time, can you guys tell me what the average inductor current is? It's the same as average resistor current. It's equal to VO over R, right? So at this point, IL average becomes exactly VO over R, right? This point, it's called, or this mode, it's called boundary conduction mode. It's a very important concept because everything, like all the formulas that we saw, this formula that we said VO is equal to D times VI, is valid up to this point. It's for continuous conduction mode and the boundary conduction mode. But if you increase the resistance further than this point, then everything we said, it's not going to be valid anymore. Okay, so let's calculate what resistance value would bring us to this point basically. So at this time, if you again remember this, if this is delta IL, this is going to be delta IL over 2, this is going to be delta IL over 2. So at this time, IL average becomes equal to delta IL divided by 2. IL average, it's VO over R. And delta IL divided by 2, it's going to be 1 over 2L. I'm just like using this formula, 1 over